Now we're actually going to calculate some pHs from concentrations. We're also going to be converting between pH and pOH. We should be relatively skilled at doing either one. After all, it really is just thinking about the concentration of hydrogen or the concentration of hydroxide, just two different ions. So, to review, when an acid dissociates in water, so we've got HCl, we call this type of reaction hydrolysis. That means it's being taken apart by the water. So it becomes H plus and Cl minus. Now when we have this situation, we need to keep in mind our definitions for acids and bases. So remember, an acid is a proton donator. So HCl has this hydrogen, this guy right here, that would be considered a proton. So HCl is an acid because it donates a proton. So then Cl minus, on the other side, what would this be? This Cl minus doesn't have a proton to give, but it could accept a proton. So now, over here, this guy was an acid, but on this side, he's a base. We have a term for that, and it's going to be really important shortly here. It's called a conjugate base. A conjugate base is the base that you get when an acid dissociates. In the same way, let's use good old sodium hydroxide to look at if we start from a base, NaOH. All right, okay. So this is right here going to be a positive ion. This is a negative ion. When we go over here, this OH plus Na plus, just like that. This OH right here, this guy right here, that's the base. So this is a base. Because he's already in here, this whole thing is also a base. So when we have this situation, by the same definition of being able to accept or donate a proton, well, this Na plus technically has an extra proton to give. So this Na plus becomes the conjugate acid. Okay? So we start with a base. When it breaks up, we get the conjugate acid. If we start with an acid, when it breaks up, we get the conjugate base. So this could connect with a hydroxide, thus reducing the content of an acid. There we go. So we need to keep this in mind because it's going to come into play later. But for now, all we need to recognize is when this splits up, based on the concentration of this, we're going to have a concentration of hydronium ions. Based on the concentration of NaOH that we dump into a solution, that's going to impact our hydroxide concentration. Okay? So with those concentrations, let's do some calculations. So right here, I have H3O+, that's my hydronium, so that means acid. I've got a concentration of 1 e to the negative 10th. All right, so if I bring this in, let me write that down, that's 1.0 e to the negative 10th molarity. So that's our concentration. If I want to figure out the pH of this, then what I really need to do is take the negative log of that concentration. So when I see negative log of this, what that means in brackets, that's the actual number of that concentration. This will become fairly common in further levels of chemistry that will use a little bit of algebra and we'll need to put a concentration in. So we put this brackets in there to tell us which element that is. So this is just this number. So I'm just going to take this number, just like when I'm doing algebra, just plug it in here. So I'm going to get the negative log of 1.0 times 10 to the negative 10th equals, and when this is just 1.0, these are really easy to figure out. Because 1.0 times 10 to the negative 10th, well, the log of that is just going to be 10. Nice and simple. So that's our answer for the first one. If we had something that looked like, let's say, my concentration was, let's say it was 4. If it was negative log 4.0 times 10 to the negative 10th, well, then you're actually going to need to put that into your calculator because this isn't going to come out to exactly 10. It'll be 10 point something or 9 point something. I forget off the top of my head. So put those into your calculators, take them on through. So what about the next section? The next section is we're going from a pH to a concentration. How do we do that? Well, to do that, we need to remember that a log, when we take a log x equals, let's just say A, well, 10A equals x. That's the relationship between logs and exponents to the power of 10. Well, from the 10 to the power of that exponent. So when we have a pH of 5, if I want to find the hydronium concentration, all I do is I take 10 to the 5th equals the concentration. Okay? But keep in mind, every time we do this, we're doing negatives. So it's got to be the negative of that pH. So it's not just 10 to the 5th, it's 10 to the negative 5th. So my concentration, this one, you should be able to do in your head, 10 to the negative 5th is just going to be 1 times 10 to the negative 5th. Fancy dancy. But again, if we have a pH that is something different, like look at the next one, it's 2.5. If this is 10 negative 2.5, you'll actually need to put that into your calculator in order to find out what the actual concentration ends up being. Okay? But overall, not too difficult. It's just punching some numbers into a calculator. The challenge here is really just going to be to figure out when do I use the concentration. Well, you're going to use that concentration when you're given that number. Okay? You're going to use pH. You're going to use pH when you're given pH. Okay? There we go. So we're just practicing these little equations. All right. Next up, we're going from pH to pOH. The key here is to remember that pH plus pOH is always going to equal 14. No matter what our numbers are, it's always going to equal 14. So if I'm given the pH, 12.8, so 12.8 plus pOH equals 14. Well, this is just like any simple algebra, right? Think back to 8th grade. It feels confusing because there's these extra letters here. But this is the same algebra. This is the same math as if I went 12.8 plus x equals 14 and told you solve for x. You could do that, right? You just take 14 minus 12.8 and you get x. So in the same way, I just take 14 minus 12.8, you get my pOH. Okay? So then, calculate the pH for each of the following pOH. That's going to be the exact same thing. Because this is addition here, you're just always going to take 14 minus whatever that number is, and that's going to give you your pH. Okay, last two. We go from the hydronium concentration to the pOH. Ooh, how are we going to do that? Well, what we're going to need to do is we're going to need to remember that if I'm given, I'm given the hydronium concentration, so I need to go negative log of that concentration equals pH, and then remember this guy up here. So I'm going to need to do two steps now. If I want to figure out the pOH from the hydronium concentration, well, then I'm going to need to do the negative log of that concentration and then take 14 minus that number. Okay? But overall, it's just two steps. It's not too difficult as long as we get a good hang of this. Right, so that's how we do this one. Now going from the concentration of hydroxide ions to pH, we're actually going to do the same thing. So in that case, we go negative log OH minus gives us our pOH. OH, and then I can just take 14 minus POH will give me pH. There we go. So these look like weird calculations. They look like they're really challenging. Ooh, doesn't want to move on me. But once we learn how to put the log into our calculators, like honestly, that's the most challenging part of this, is because some calculators have a quick button for that, others do not. If you're struggling with that, let me know, we'll figure it out. But once you get past that, it's just plugging variables into equations. It feels confusing because the variables look confusing. But if it helps you to think of it this way, let's just call pH X, POH Y. Call your hydronium concentration, call that A, hydroxide concentration B. So any one of these equations, you could simplify it just plugging in different numbers, different letters, different symbols, and that'll actually make it look just like a regular math problem. And I think if you did that, you'd go, oh, this is easy. I've done this before. It's just confusing because we're trying to add a real life concept on top of a mathematic concept. Okay? Any questions? We'll talk about it tomorrow. We're meeting. We'll be fine. It'll be great.